Hello everyone, in this video we'll be solving problem 118 Pascal's triangle. The problem statement is given an integer nums row, return the first number of rows for Pascal's triangle. In Pascal's triangle, each number is the sum of the two numbers directly above it as shown. Let's use this triangle to understand how Pascal's triangle works. For row 1, there is only going to be one element. For row 2, we'll have two. These are given. But for row 3, first and the last elements will always be equal to the last element of the previous row. But the one in between, which is 2, this is the sum of the two elements above it, which is 1 and 1. Similarly, for row 4, the corners are going to be the same, but if you look at this element, this should be the sum of the two elements above it, which is 1 and 2. Hence, the output is 3. Similarly, for this, we are adding this 2 and this 1. This is how we populate or create a Pascal's triangle. We'll be given the nums row and we need to return all the elements in each row when we are building the triangle. I hope you were able to understand the problem and how Pascal triangles work. Let's switch to whiteboard and discuss how we can solve it efficiently. As you may have noticed, when we were calculating the values for row 3, we are actually relying on the calculation that we have done for row 2. Similarly, for row 4, you are relying on the calculation that we did for row 3 and so on. So we need to use the previous calculations when we are doing the current calculations. This is a very important point that we need to remember when we are solving this problem and looking for an efficient solution. The solution to solving this problem is to use dynamic programming, where we are saving the previously calculated value and using it to calculate the current row and continue this logic as we move forward. Let me show you how we can do it on a whiteboard. So we'll maintain a variable called previous calculations. There are a couple of calculations that are given to us, starting with the elements on the corner. For row 3, the elements on the leftmost side are always going to be ones or equal to the corner elements of the previous row. So we don't have to do any calculations for this. We only have to calculate the item in between.
And the total number of elements in each row will be equal to the row number.
So when we are creating a new array for each row, we'll use the row number to determine the length of the array. Let's do the calculation for row 3. When we are at row 3, the previous would be row 2, R2, so its value should be 1, 1. And as we have already calculated the corners of row 3, we only need to calculate the value of the middle one, which is the sum of two elements above it. Current of 1, which is this element, is previous of 0 plus previous of 1. This is at index 0 and this is at index 1, which will give us 2. So we can save 2 in the middle element for row 3. It may not make sense right now, but when we do the calculation for row 4, this will be more clearer. Now let's calculate for row 4. We'll have 1 and 1 at the corner and we have two open elements. My previous is now 1, 2, 1. Because the elements in the array are now increasing, to populate all the elements in between, we'll run a for loop which will start with I is equal to 1 and run until I is less than
Previous dot length.
and then I plus plus. So when my I value is equal to 1, previous will be 0 and the other previous would be 1. So for this position, I need to add I from the previous array and I minus 1, which is 0. So 0 and then 1, adding the 2, I'll get 3. I'll save it and then increment my I. So the new value will be 2. I is equal to 2. My previous should be I minus 1, which is 1, and I, which is 2. So 2 and 1, which will give me 3. And we are done with our for loop. Let's do one more run for row 5. So my previous is now updated to row 4, which is 1, 3, 3, 1. For row 5, I have 1 and 1 on the corners, and I have 3 elements in between. So starting with I is equal to 1 for this position, I'm looking at I minus 1 and I on the previous 0 and 1, which is these two, its total is 4. I will save it and increment my I. My new value for I is 2, previous is now 1 and 2. Adding these two elements gives me 6, and similarly the last one will give me 4. With this solution, our time complexity is O of n square, where n is the number of rows, and the space complexity is O of n, because we are using this variable to maintain the previous state, as we need to calculate the values for the next state. Let me show you how we can implement this using C#. In this solution, I initialize the results variable, which is a list of lists. I then check if the number of rows is greater than or equal to 1. If yes, then I'm adding the first element into the results. If the number of rows is greater than 2, then I'm adding one more element to the results array, which is 1, 1. This is the equivalent to the element needed in row 2. And I'm also initializing the previous array, which contains the value of R2 or row 2. I then start the iteration for the rows, starting with I is equal to 2, I less than the number of rows. I then call this iterate method, passing in the previous array that we have calculated. This iterate method will help us build the array for the current row based on the previous calculation or the previous row. So I'm initializing a new variable of type integer array called current, and its length is set to the previous length or the previous array's length plus 1. Then I set the default values, which is the first and the last value, whatever is the value in the previous array. I then start a for loop to fill out the remaining elements in that current array. So starting I with 1 until I is less than previous array dot length, and then adding the previous arrays I minus 1 and the current I, two elements above the current one. After this for loop is complete, I'm returning the current array. Once I get the current array in this variable, I'm adding it to the results variable, which is being returned at the end. After saving the value in the results array, I'm replacing the previous variable with the current variable value, which will be used in the next run. After this iteration is done, we will have all of the arrays for all the rows in the results variable, and we can return it. This solution, when submitted on LeetCode, beats 100% of the submissions so far in terms of runtime complexity, and in terms of memory consumption, beats nearly 11%. Thank you for watching this video. I hope you were able to understand this explanation and the solution. The link to the solution is available in the description below. Feel free to check that out, and I will see you the next one. Thank you.